Hi, my name is Sam and this is my entry for the Moog Circuit Bending Challenge 2017. This year I decided to bend a Yamaha PSS-380 and the modifications that I introduced are pitch bend and switching between the original clock and the one that I built around the 1799 chip. I like dependent resistors that can be activated through a switch that allow me to control the pitch, a potentiometer that allows me to control the pitch, then a reset button, an overdrive switch, 8 data line switches that interrupt the flow of data between the FM chip and the CPU, 6 buttons here on the breakout box that introduces random sequences plus an LFO. So let's give it a spin. The keyboard came in mint condition. Like there are 100 sounds that are quite nice, but there is an FM synthesizer, so you can modify sounds. Actually. So yeah, let's go and bend it. Right, so here you can see the FM chip. There is this one, and this is the crystal, the clock that we're gonna hack so that we can change the pitch. Here we're gonna cut the data lines and I'm gonna wire them to some switches so that we can disrupt the flow of data through between the CPU and the FM chip, that is the sound generator. And here we have some more IC, and I don't know what they do really. Like, I mean, I know that the big one is the, well, it's out of progress actually. I know that the big one is the main CPU of the keyboard. So here there will be the matrix as well for the keys and blah and so on. But these two, I don't know what they do, but I want to try to see what's gonna happen if we start jumping wires around. Right, so to do the modification of the data lines in this keyboard, you can see there is like this blue thing, so basically that means that there are overlayered circuits. So here I disordered all one side of the FM chip and there is a cut in between the third pin because that's where I'm gonna do the hack of the clock. But coming back to the FM chip, here on this side I'm gonna solder my wires. Here on the other side we have the FM chip that I just desoldered, this one here, I don't know if you can see, and here I'm gonna bend all these pins that are coming out, and I'm gonna wire the other end of the switches that I'm gonna use in order to interrupt or reconnect the data line. There where you can see that big mass of wire is where I place the data line modifications. So the internal clock that you can switch through this red switch here, and then the one that I introduced, that is this circuit here, that is an LTC 7099 base oscillator, and that is what I'm gonna use for the pitch bend. But also here I prototyped an LFO to see if I can modify the pitch, and so let's have a look. I'm gonna play the demonstration song so that, because it's all upside down, I can't access it properly. So what you will hear first is the original clock. Quite nice and funky. Let's go with the clock modification. And there is also like dependent resistors, so I can use it more or less as a theremin. You can see here. Quite a nice effect. Right, and the funny thing is the LFO. So if I wire it up, so you can hear the LFO. There's that guy there acting. So it's modulating the pitch. So these are all freebies I got from my college where I work, and I will use them for patching the controller, the external controller I intend to build inside the keyboard, so that I can modify all the parameters through a breakout box. So I finished wiring the data lines and the oscillators that allows me to control the pitch of the keyboard. The next thing I'm gonna do is, right, let's see if you can see. This is the breakout box that I'm gonna use as a controller. So the color push buttons are gonna trigger random sequences of sounds from the keyboard, while the three knobs above are the LFO controls. So the one on the left is the speed or rate, the second one is the shape, so it goes from a square wave to a triangle wave, and the one on the right is the depth, so the amount of LFO that is gonna affect the sound of the keyboard, in this case the pitch. To do this, I'm gonna use, to connect the breakout box to the keyboard, I'm gonna use this guy here that is a parallel port from an old computer, and it's stuff that I find in the recycling, together with the actual cable. So this one will allow me to control different parameters, as there are 18 cables inside. So I just need to find the color code for the pins, and then I will wire this one into the keyboard and this one, the cable, out of the breakout box, so that I can connect it whenever I want and use it as a controller basically.